Hello YouTube, I hope you're all keeping safe. We're locked down again in the UK, but well, I'm here in the shop on my own, not spreading the virus, and I've got one of these exhaust cans to do a fairly substantial repair on. Thought it might entertain you a little bit, so I've made this end off camera, but I've got another one to do, so I can sort of show you how I did it, and hope you enjoy. So the first thing is to cut out a sheet, and I just took and used my plasma cutter. Now I have a video called Getting the Most Out of Your Plasma Cutter. It's basically simple tips using guides, and you can cut really accurately with one if you really need to. So check that out. Next thing to do is to take the disc over to the lathe, and we're going to put a hole in the middle, a little bit smaller than the hole we want, because we're going to do some sheet metal work on it. Now, this old Tony, with your time travelling lathe, I got a little bit jealous, and I decided to kind of perk up my old Colchester student a bit. I know you've got one, it's very nice. So this one's jet powered, and I'm now going to fire it up for the first time, see how it works. Alright, I'm watching for a hot start. My exhaust gas temp is on the lower scale. It's peaked at 1500, it's coming down. The RPM's going up. That's a good start. We're going to take the revs up to 115% now. See what happens. I guess they don't fit chuck jaws the same way they fit propeller blades. You know what? I think this old Tony is an expert at lathe modification. I'm going to leave it to him. Back on old-fashioned electrical power, I'm just taking this centre hole to the diameter that I want. And now what I need to do is modify the mandrel that I had to make the first one for the different size centre hole on the second one. This other end disc has a smaller hole in it. Okay, I'm being really clumsy today with the verniers because I'm trying to do it with one hand and hold the camera with the other. I've got inch 105 there, and the dimension that I'm after is going to be, if I can get my cack-handed fingers to work, dimension I'm after is going to be inch 350. Does that mean I got to take off 245 thousandths? No. Yes. Jesus. Maths. I think it's 245. Tell you what, I got a better plan. As my brain's not working today, we will set the DRO to inch 105. No, that's not right. Numpty. Come on, get your head going. 105. Even that's not right, is it? I need to set the DRO to inch 350 and wind the handle to inch 105. Right. Wakey wakey. Inch 350. And wind my x-axis to inch 105. I'm gonna... I confuse myself on a bad day. Here we go. Let's just do a complete brain recalibration. I can't even speak now. I'll tell you what, I'm not going to cut that all the way. I'm going to do a bozo check on that one. Is it? Yeah, that is the same size. Right. Thank God. I find since I've been using the DRO on the lathe, I've forgotten how to do maths, which might be a good thing at my age. And since I've been using digital micrometers, I've forgotten how to read verniers and quickly add and subtract as well. Maybe I should keep myself more mentally agile by banning myself from modern technology for a while. But I don't know. I think we're ready to do a little bit of friction turning here. I'm just going to press something against that using my tailstock. I need to deburr it first. Alright, here's my setup. Friction turning can usually work. Just going really carefully. I just want to make this disc round. Oh, there's me preaching about being careful with your plasma cut, and I didn't get it very round at all. However, it won't take many minutes just to... Oh, just stop turning. I think there's a notch in there where I pierced the sheet, a hard notch. Let's just try a different plan. If I just take small cuts and come across it like that, rather than trying to take the full width of the thing, there's a bit less chip load on the tool. That works much better. Anyway, next stage of the setup. This is just a wheel bearing, plain wheel bearing on a bit of bar, welded to another bit of bar which is mounted in the tool post. I'm just going to use this with the lathe on its very lowest speed to gently start to form this disc over the former that I've made there. It worked once, it should work again. I don't want to put too much stress on things doing this, but I'm just feeling it. I'm feeding gently by hand, I'm just feeling the pressure. So far not too bad. This is annealed stainless. It will work hard, and that's why I'm using a slow speed and trying to get it down reasonably quickly, not let it keep springing back against me. But you can see it started to tip there, and I've worked it a bit more, changed the angle. The final work on this had to be done by bludgeoning. I felt I was putting a bit of pressure on the lathe and the tool post, so I just got a little hammer and started working my way around there, carefully, tabby tap tap. It's difficult to do through the camera viewfinder, but I keep missing when I do it through the camera viewfinder. And it's only a small hammer. Anyone worried about my lathe and my headstock bearings, it's a very, very heavy chuck. I just work my way around, tapping the high spots, and eventually I'll trim off any wobbly edges with a sharp tool again. See, this is a very, very heavy 4-jaw chuck. The shock's being transmitted to the headstock and the tailstock. It's no more than if I was doing an interrupted cut. So it's really not going to hurt anything. That's how that worked. To do the centre, I found another bit of scrap and just bored a hole in it. And all I need to do is just pop her in the vise together with a soft jaw, and I started just very gently working that centre down with the ball peen hammer, the ball end of the ball peen hammer. Some people aren't going to like this, but it worked just to start it going in the right direction. Tabby tap tap all around that. That worked, and then on the other one, once I'd got it going the right direction, I put a tube expander in it and just stretched it out. But my tube expander won't fit down the middle of this hole, so I'm going to turn a little sort of tapered forming tool and just press it through, I think. But that's going to be for the next video. Needless to say, the one I've done so far using the pipe expander, I think it's turned out pretty good. I've welded the 2-inch pipe on. It'll need a bit of polishing and bead blasting, but one end of the can is done using that method. I'm going to get this sheet rolled to form the tubular centre bit, and then there's a few little bits of hammer formed sheet going on the edge. So I say I'm going to finish this one off in the next video, because I'm going to turn up a little pressing die to push into the centre there, because I think that's a better way of doing it. yeah, in hindsight that is a better way of doing it. So that's the end I'm making now. That's the tube that's got to be rolled. The rest is just some little angles and bits welded on to hold a shroud. Shouldn't be too difficult. If you like what you see, please do like, share and subscribe. And I hope that's entertained you a little bit in these difficult times. Thanks for watching and good night.